Good morning, ladies and gentlemen. We are going to start the topic of free fall. Now, free fall, right? Think about what we say and what free fall means, right? I like to think of skydiving, cliff jumping, right? All of those are forms of free fall. Now, yes, you got to be crazy to do any of those things, but hey, some people do enjoy them. Me, I like to keep my feet on the ground. I have this great video for you guys to watch. It's a really good music video called Free Fallin' by Tom Petty. So take a look at that. We will be playing that in class multiple times. So what is free falling? Free falling is an object moving in the vertical plane that is being acted upon solely by gravity. So the vertical plane, we're talking about up and down, right? Objects accelerate at constant rates. Mass does not matter for this. So we have acceleration due to gravity, or as we denote that with a little g. All right? Little g is equal to 9.81 meters per second squared. Now, gravity, we only really experience gravity close to the surface of the Earth, right? That's due to the gravitational field strength. The further away you go from Earth, the less gravitational pull you will feel. On the moon, gravity is 1.62 meters per second squared. Gravity here is 9.81 meters per second squared. And then you have Jupiter. Jupiter is 26 meters per second squared. Now, 26 meters per second squared is enough pull that you will be crushed if you went to Jupiter. We are never going to talk about air resistance. We do not care about air resistance. We always neglect it. Here's a video I have for you guys on an astronaut who went in outer space. He dropped a feather and a hammer. Now, which one do you think dropped first? Now, watch the video to see if you were right. Once you're done with that video and you have thought about what happened in that video, take a look at my last video for you. This is a video of the longest free fall that has been recorded. Really great video. It's with Felix Baumgartner. Please make sure you watch it. Now on to some of our information. We have the kinematic equations. Now guys, these are equations we're going to be using to solve these free fall problems. So, what are these equations, you ask? Well, one equation is this. We have VF is equal to VI plus AT, where VF is your final velocity, right? We all know that. That's nothing new. VI is your initial. Again, nothing new. A is going to be your acceleration, right? Now, if we're dealing with free fall problems, your acceleration here is going to be 9.81 meters per second squared. And then you have t. We've dealt with t all this time, and that's just time. You see what I did there? Time. So that's one equation we're going to be dealing with kinematics. Our second one is going to be d is equal to VIT plus 1/2 AT squared. Well, you may ask me, what do all these stand for? Well, this is where d is going to be your distance. VI, as we all should know, is your initial velocity. T is your time. And A, again, is your acceleration. Now, when dealing with free fall problems, our acceleration will always be 9.81 meters per second squared. That is equation number 2. Now, there's one more equation. So let me just use my eraser. And we're going to erase all this, right? Give me some to give some space so we can write our last equation. Right? I hope you guys all took the time to write down these equations. Right? We will be using these often. Okay, the eraser's a little slow, but that's all right. We'll get it to work, right? All right. That's enough. Our last one we're going to have. So number 3 is going to be VF. VF squared is equal to VI squared plus 2AD. Well, again, this is where VF is your final velocity. Right, and this part should just be a review. VI is your initial velocity. A is acceleration. And D is your distance. Right, so that's your 3 equations. It's very important to understand and know. So, moving on. We have 3 scenarios in free fall. When we are dropping something from rest, so that means that VI equals 0 meters per second, and it falls to the ground. You throw something down, right? So again, we have this object, we're throwing it down. So now our VI becomes some number. And you have when you launch it upwards. I have my object here, I launch it upwards. Well, what happens? It goes up, hits a point, then it comes back down, right? VI will equal something, some number. Those are our 3 scenarios. Well, let's talk about scenario 1. An object dropped from rest. So first thing you must do is you must determine which direction will be positive and which direction will be negative. So you have your object here, right? We'll draw it out a little bit. Object here, it's being dropped. So ladies and gentlemen, this going down is going to be positive. If you go up, it will be negative. We are looking for what VI is, A, VF, D, and T. Well, because we're talking about free fall, we know that A is 9.81, right? We know that A is 9.81. We know that our velocity will then be 0 meters per second. And you may have to solve for VF, D, and T. What can we tell from this scenario? If I drop something, what happens to it? It speeds up. So if something speeds up, it must be accelerating. Again, if something speeds up, it must be accelerating. Well, let's do an example. How long does it take for a book to fall 6 meters from the classroom window to the ground? Well, just like we've always done, write out your givens. What are we given here? Well, we automatically know we're dropping it, right? So we know that the VI is 0 meters per second. It says it falls a distance of 6 meters. And it falls from the classroom window to the ground, right? We want to solve for the T. Well, what else do we know when I say free fall? I've told you this multiple times. Free fall, our acceleration. We have an acceleration, right? When you drop something, it speeds up. So our acceleration always for free fall is going to be 9.81 meters per second squared. And then you have your T. Now, out of those 3 equations we have, right? VF equals VI plus AT. D equals VIT plus 1/2 AT squared. VF squared equals VI squared plus 2AD. Now, for our first equation here, do we know what VF is? No, so we cannot use that, right? We don't know what VF is, and we don't know what the time is. So no, we don't want that one. What about this? Again, we don't know what VF is, and we don't have time in there, so we can't use that one. So we want to use this one. This is a winning equation, right? So writing out our equation. D equals VIT plus 1/2 AT squared. Now let's do our plug-in. Doing our plugging, our distance is 6 meters. Our initial velocity is 0. So that's going to be times t, and we know anything times 0 is 0. Plus 1/2, our acceleration is 9.81 times t squared. Okay, let's break this down even further. We have 6 here. What's 9.8 times a half? 9.8 times a half is 4.5, and we multiply that by t squared. Well, we need to get t by itself. We're solving for time. Divide by 4.5, divide by 4.5. T is equal to what, ladies and gentlemen? We should be plugging that into our calculators. 6 divided by 4.5, that gives you 1.33 seconds. We always round to the hundredths spot. And that's how you solve for this problem. It took the book 1.33 seconds to go from the window to the ground. Let's do one more. You drop a coin down a dark well and you hear it hit the bottom 2.5 seconds later. How deep is the well? Assume the time delay for the sound to come back is negligible. That means that we're not worrying about it. Well, let's write our givens out. You guys are thinking, Mr. Foster, this is a lot. No, it's like a puzzle. Just gotta take your time and go step by step through it. For our givens, what do we have here? Well, we automatically know we're dropping something, right? So A is going to be 9.81 meters per second squared. Always going to be that when we're in free fall. It says T is 2.5 seconds. We know that VI is equal to 0 meters per second because we're dropping it, right? It's dropping from rest. And it wants us to solve for the D, right? It wants us to solve for what the distance is. Well, we already know. We got an equation for that. D equals VIT plus 1/2 AT squared. Right, there's our equation. Now, let's do our plug-in. Our plug-in here, we're trying to solve for D. So we have D equals, VI is 0. So anything times 0 is 0, plus 1/2, 9.81 meters per second squared, times our time, which is 2.5, and we have to square that. D is equal to 1/2 times 9.81 is 4.5 times 2.5 squared. 2.5 squared is equal to 6.25. Let's multiply those together. And you get the distance of that well was 28.13 meters long. And so, ladies and gentlemen, that is how to solve for problems when you are dropping something from rest. I'm dropping something. All right? So if you go onto the classroom, I will have the PowerPoint uploaded for you guys to go through again on your own. I will also have your free fall worksheet for you guys to complete for Thursday. Well, I hope you guys have a great Wednesday. We'll talk to you on Thursday.